I'm Teacher Im. For those who are new here, I prepare videos to help my students score in their STPM SEM paper. I hope the videos are useful for you too. If they are, please give me a like. Today we are going to talk about differentiation of inverse trigonometric functions. The formulas for inverse trigonometric functions, you can find them in the formula list in your exam paper. We have the differentiation of inverse sine, differentiation of inverse cos, and differentiation of inverse tangent. And they will transform into simple equation like this. Let's check out the examples. Let's say if I have y equals to sine inverse 2x, when I differentiate that, I will get 1 over square root of 1 minus the function squared, and I need to differentiate the function and put at the side. It looks a little bit different from the one that they showed in the exam paper. It is actually the adjustment of the formulas that we are given in the formula list. How do we use them? Check this out. What we do is, we will follow the formula exactly. So 1 over square root 1 minus the function itself. For this case, the function is 2x. The function squared, and we will differentiate 2x and get 2 and put at the side. Once that is done, we just need to simplify it. For this case, we just combine the 2 into the square root. Like this. That's done. Okay? Very basic. Let's consider this question. The one that I have is y equals to sine inverse x over 2. What you need to do now is use this formula, fill them in. So 1 over square root 1 minus the function. So for this case, the function is x over a. So I have x over a squared. Then I will differentiate x over a. Since a is a constant, so I will get 1 over a, just like what I did in previous question, where I have 2x. So when I differentiate it, I get 2. But for this case, when I differentiate x over a, I get 1 over a. It's time to simplify. So before I do anything, I need to combine this part. So I take a squared multiplied by 1. So I will get a squared minus x squared. So here is x squared over the whole thing a squared. So a squared. Next, I need to simplify this square root. So the only part that I can clear away is a squared. So I will put a squared 1 power of 1 over 2. Actually, this step, you can skip it if you want, because if you know that square root of a squared is a, you can just skip the step and move on to this step. What will happen is, because this is 1 divided by this function, so we can alternate it, bring the a to the top. We copy the denominator here and in this denominator. So a and a can be cleared away now. So we are left with 1 over square root a squared minus x squared. I hope you are following. It's easy. Next, let's look at this question. We have y equals to cos inverse x over 5. We are going to need this formula. Let's fill them in. So we have negative 1 over square root 1 minus, the function is x over 5. So we are going to put in x over 5 squared. Differentiate x over 5, we have 1 over 5. Now, once we have x squared and 5 squared, we will have 25. We are going to combine them to 25 times 1, we have 25 minus x squared. Square root of 25, we will get 5. So you can skip this step and move on to this one. We will have 5. When we pull them up, we will have negative 5 over whatever functions that we have here. We just copy them down and combine and simplify. So simplifying this will end up with this part where that's the answer already. Okay? If I have x squared minus 1 with cos inverse x, when I differentiate them, I still use the same formula. What I'm going to do is I'm going to put in x squared minus 1 inside the place of fx. So I have 1 minus my function x squared minus 1 squared multiply by differentiation of the function. So I have 2x put at the side. Next, I need to expand this. I need to expand x squared minus 1. So I will get something like this. Arrange them properly and you will get minus 2x over 1 minus 1. The 1 will disappear. So what's left is 2x squared minus x to the power of 4. Once that is done, I can actually factorize out x squared from the denominator. I can simplify it into x and divide them with the x from the numerator. And that's the answer. So I will get negative 2 over square root of 2 minus x squared. How about this question? The formula I'm going to need here is the inverse tangent. Differentiation of inverse tangent. I have 1 over 1 plus fx squared. It's almost the same like the previous one without the square root. So I'm going to get 1 plus the function for this case is 1 over x. So I just copy it down. And differentiating x to the power of negative 1, I will get negative 1 over x squared. So it's index to the front, index minus 1. So I get negative 2, so it transforms to the denominator. After this is done, I need to combine this part of the fraction. So x squared multiplied by 1, I get x squared plus 1 divided by x squared. Once this is done, I need to transform this to, so the denominator here will go up, so it's get x squared over x squared plus 1. These two can be cleared away, so my answer is only going to be minus 1 divided by x squared plus 1. That's the answer. Super easy, right? Now, let's check this out. I have a bigger function here. So in this function, you can see actually it is a division. So it's a quotient rule. So other than the inverse tangent, differentiation of inverse tangent formula, I also need to have the quotient rule formula prepared. Of course, in exam, you don't write out all these formulas. You just memorize them. But I do like to list out my formula so that you can understand which formulas I'm using. So, I will first start by applying them into the inverse tangent formula. So, what will happen here is 1 divided by 1 plus the function squared. So the function here is x over 1 plus x, so I will have x over 1 plus x squared, followed by the differentiation of x over 1 plus x. That will give me this quotient formula. So I will copy v, so it's 1 plus x, so I will write them on top. Differentiate u, so my u is x, so differentiate x, I get 1. The minus, so I have minus here. Minus u, so my u is x, so I copy the x. Differentiate the dv over dx, so for this case is 1 plus x, so I differentiate 1 plus x, I get 1. Divide everything with v squared, so v is 1 plus x, so it's 1 plus x squared. Now it's time to simplify. Before I can do so, I need to combine this part of the fraction. So 1 plus x multiplied by 1, so I have 1 plus x squared. Here is x squared, so I have x squared, divided by 1 plus x squared, so I have 1 plus x squared here. Over this side, I just need to simplify it by multiplying the values inside. You can straight away jump to the next step, which is 1 here. Okay, now let's have a look. Is there anything you can clear away? Yes. So I'm going to clear away 1 plus x squared with this denominator here. So what's left is 1 plus x squared plus x squared. I can straight away open this bracket into this format when I'm doing this step. So this will open up and I can combine these x squareds. So what I am left is 1 over 1 plus 2x plus 2x squared. It is done. Let's check out number 7. Next, in this question, we have y equals to inverse sine and the function given in there is a cos x. So the formulas that we are going to need is the differentiation of inverse sine formula and also the differentiation of cos x formula. For those who have not seen my differentiation of trigonometric function, which comes in 2 parts, I will link it in the description box below. Please check them out. Differentiating this function, I will get 1 over square root of 1 minus cos x. So that is from my formula here. So the function inside there is cos x. So cos function squared, you will have cos squared x. Differentiating cos x, I will get negative sine x. So I will write them at the side. Next, I'm going to consider this identity formula because I need to transform the one in the bracket into sine squared x. What will happen now is the whole thing here is going to change to sine squared x. So the square root of sine squared x, I will get sine x. I can finalize my answer by getting negative 1. In this question, I have ln and inside the ln I have tangent inverse x. So the formulas that I'm going to need is the ln formula, and again, if you have not seen the differentiation of ln functions videos, please check the link below. Now I have ln fx can be differentiated into 1 over fx and differentiate the function put at the side. Next, I'm going to need the tangent inverse formula that will give me these formulas. So I can combine them now. So differentiating ln, I will get 1 over the function. So in this case, the function is tangent inverse x. So 1 over tangent inverse x. And differentiating the function itself. So the function is tangent inverse x. So differentiating tangent inverse x, I will get 1 over x squared. So I will write that at the side. Once that is done, I just need to combine them together in this format, and there's nothing else I can simplify because they are all from different functions. So I have a quadratic here and a trigonometric function here. Okay, so I cannot combine any of them. So this is the answer. In this question, we have exponent combined with inverse trigo. Again, we have the differentiation of exponent formulas. If you have not seen the video, please click in the link below. And we have the inverse sine. This looks scary, right? But don't worry. It's actually combining the formulas into the question. So differentiating dy over dx, I get exponent gx. So exponent and the function. So I have exponent and the function. So the function is inverse sine x over 2. So I just copy them down. Next is I need to differentiate the function. So differentiating sine inverse x, I will have this formula to help me. Remember, this formula is given. You just need to adjust them to suit you in the question. So I have 1 over square root. So 1 over square root 1 minus function. So the function here is x over 2. Okay, so I have x over 2 squared multiplied by the differentiation of the inverse trigo. So the function inside the inverse trigo, which is x over 2. Differentiating x over 2, we will have 1 over 2. Now, let's combine this part here. Right? So I have 1 minus x squared over 4. Now, you can consider combining straight away into this format without going into these steps. I just want to show so that you don't get confused. So x 1 multiplied by 4, I got 4 minus x squared divided by 4. So minus x squared divided by 4 here. Okay. This 1 over 2, since it's at the denominator, so I pull it and put it at the side. Over this side, I have the inverse exponent power of inverse sine x over 2. So I copy this whole thing at the top. Okay, now I'm going to simplify 2 and 4, square root of 4, sorry. So you have square root of 4, I have a 2 there. So it will clear away. So my equation is left with this. Next step is I just need to factorize the one in the square root here, and I will get something like this. Okay, so that's the end of the working. You will get your answer as so. In this question, it's given that y equals to square root 1 minus x squared is multiplied to sine inverse x. So we have a product rule and inverse differentiation of inverse sine formula needed. So we have both of them at the side here. So you can now combine them. What will happen is I copy my u, then I differentiate my v, which is inverse sine. So I will use the formula 1 over square root 1 minus x squared, copy all of them here, plus copying the v, so I have sine inverse x, and for u, when I differentiate my u, I will need to use the composite function formula. Okay, if you have not seen the video, please check them out in the link below. Now, what will happen here is 1 over 2, it will come to the front. Copy whatever I have in the bracket. Index minus 1, so 1 over 2 minus 1, I have negative 1 over 2. Differentiate the one in the bracket here, I have negative 2x. Once that is done, I am going to simplify whatever I can simplify. So for this case, I have square root of 1 minus x squared, because power of 1 over 2 is actually square root. So both of them will simplify off, and I will get 1 here, minus y minus, because I have a negative here, so multiply with the sign inverse. So I have minus x is from here, so I copy x. Sine inverse x is from there, so I copied them down. This power is a negative, so I will bring 1 minus x squared to the denominator. 2 and 2 will clear away. So what is left is this function. I just need to change the power of 1 over 2 back into square root, and that's my answer. In this question, we need the differentiation of y equals to 1 plus x squared multiplied with exponent to the power of tangent inverse x. So we have a product rule, an exponent, and an inverse tangent. So we will apply them into these three formulas. So first thing, u is 1 plus x squared. Differentiate dv dx. So my dv dx will be differentiating exponent into the power of inverse tangent x. So I need to like copy exponent, copy the function, so which is inverse tangent x. Then differentiating inverse tangent x, I will get 1 over 1 plus x squared. So I will copy all of them together. Then plus v. V is exponent tangent to the power of tangent inverse tangent x. So I copy them there. And I differentiate du. So for this case, du is 1 plus x squared. So I differentiate 1 plus x squared. I get 2x. I write it here. Now it's time to simplify. So I simplify these two away, 1 plus x squared and 1 plus x squared. I just clear them off. So exponent to the power of tangent inverse x, I copy them here. Then I have plus 2x and the exponent power of inverse tangent x again. So both of these is the same. I can factorize them out, and I will end up with this final answer. That's all. In this question, I have a quotient rule again. So I have cos inverse x divided by 1 minus x squared. So I'm going to combine this very, very carefully. So I will copy my v, which is 1 minus x squared. Differentiate du dx, which is cos inverse x. So differentiating cos inverse x, I get negative 1 over square root 1 minus x squared. Followed by minus, so follow the formula, minus. And then copy u, so cos inverse x, copy it down. Differentiate dv dx, which is differentiating 1 minus x squared, so I get negative 2x. Divide all of them with v squared, so v is 1 minus x squared, so that will give me 1 minus x squared squared. Okay, now it's time to like simplify. So what will happen here? Negative, negative will become positive. So I have 2x cos inverse x positive. I write it in front. Here I have a negative and 1 minus x squared. And here is square root of 1 minus x squared, which means it's 1 minus x squared power of 1 over 2. So 1 minus 1 over 2, I have 1 over 2. And then divide by the denominator. Next thing is I just need to change this into square root 1 minus x squared. So this is square root 1 minus x squared, and that's all. Okay? So please consider subscribing and clicking the bell button. Give me a like, a comment on this video, share it with your friends, and I will see you again in my next video, which will be derivative of implicit function. I might do a part 1, part 2 because it is quite a long video, but I might consider combining like what I did this time. Okay, see you next lesson. Goodbye and good luck in preparing for your exam. Have a nice day.